Hello, I'll be talking about Huawei's ONOS-based Transport SDN supercontroller. So first of all, why supercontroller? Obviously, in traditional network systems, the provisioning of services across domains, layers, and across many vendor equipment sets is a difficult proposition in terms of integration. So the supercontroller is a response to this. It allows a first stratum of vendor-based domain control such that vendors can leverage existing control plane processes, present management abstractions in the form they wish. The supercontroller, though, is a stratum fully open and open source based that sits on top of this. It accepts either directly or via an adaptation mechanism standard, industry standard based abstractions such as the IETF Yanz models. The supercontroller is able to produce converged topology abstractions across all of these domain sets and then present both synthesized topologies, again, on an open standard basis from across those confederated domains, and accept service provisioning inputs pertaining to the whole stratum. Okay. So now on to the demonstration. This is composed of the ONOS-based transport supercontroller prototype and several Huawei domain controllers controlling Huawei network equipment in this case. But of course, the idea is that any vendor domain controller presenting the or adapted to the standards-based northbound abstractions is integrable from the supercontroller. So the first thing we can leverage is a topology interface. This allows us to get topology presentations from each of the controlled domains to synthesize these into a single converged transport topology presentation. Okay, now for provisioning services, we can make use of a services interface to the supercontroller. And of course, there are various ways we can leverage path computation on the topology within the supercontroller to synthesize end-to-end services. For example, based on lowest latency, shortest topological distance, that is shortest hop, or anything else we might require. In this first demonstration, we'll do a end-to-end service provisioning based on shortest hop, that is shortest topological distance, so traversing the fewest net domains end-to-end. Now in this next end-to-end service provisioning demo, we'll focus on lowest latency. In this case, we've assigned latency attributes to all the links. Therefore, in the converged topology visible in the supercontroller, we can base our end-to-end service computations based on the latency target. And in this particular service instantiation, we will go for a lowest available latency between two service provisioning points. So this was a first demonstration of an open source standards-based transport supercontroller. We see this, the hierarchical or supercontroller concept, based on both open source and open standards for interfaces among the system strata, as being really key to enabling what Transport SDN has missed so far, and that is a real opportunity for non-vendor locked systems to be deployed that nonetheless provide effective end-to-end control over multiple vendor systems. Thank you.